welcome to Engineering Simple. In this video, I'll do a quick calculation on how to calculate the apparent power. This could be an example or a question that would be on the FE or P exam, so it's good to know. So let's assume we have a three-phase system. So I'm just drawing a bus. So this is a three-phase, but I'm just drawing the single line. So I have a bus, and I have a load, and I have the current that flows through this load is 16.9 amps with an angle of 30 degrees. And the voltage at this bus is 1200 or 12.47 kV. And it's 7.2 line to, so this is line to line, this is line to line, and this is line to neutral. And this is connected a grounded Y load. And the angle of this voltage is 80 degrees. So the question is, what is the apparent power? So I'll just kind of solve it to the side here. So it's good to know what is given and what is asked. So let's start with the question, what is the apparent power? The apparent power basically is the magnitude of the complex power. So that's the apparent power. So in general, we know the complex power of a three-phase system is equal to square root of 3 times the voltage line to line times the line current, but that's with a conjugate. So square root of 3 times, I know the line to line voltage is 12.47, and that's kV. So I have an angle of 80 degrees, so that's kV, times the current, which is 16.9, which is with an angle of 30 degrees, so that's in amps, but I have to put conjugate here, so it's important to remember that, especially if you are asked to calculate the phase angle. So then I'll just come back here so I have more space. So the complex power is equal to square root of 3 times 12.47 kV with an angle of 80 degrees times 69. So I want to get rid of the conjugate. So 69. So I have a conjugate, that means I have to invert the sign of the 30. That means since it's positive, I'm going to make it negative 30 amps. So now square root of 3 times 12.47 times 69. So keep in mind, this is kV, this is amps, and I can put the angles here. So I have 80 degrees plus minus 30, which is just minus 30 degrees. So if you carry out the calculation, you get 1490.26 with an angle of 80 minus 30 is just 50 kVA. So the takeaway is So if you do, so for three phase, obviously you can do either, since I use the line to line here, and the line to line current here, I use square root of 3. Obviously, if you want to use all quantities in line to neutral or per phase, you would do 3 times the line to neutral voltage, in this case would be 7.2 kV, times the line, the per phase current, but since this is a Y, the line current is the same as the per phase current. So you need to know like how to write the equation for the complex power. So it's important. And you have to remember the units you see here. It's kV, here is amps. So if you forget kV, or if you didn't multiply by 1,000, you're going to be off by 1,000, which is a lot. Unfortunately, on the exam, they tend to give you, so you are going to be given 4 choices. One choice is the correct answer. One choice might be where you forgot to multiply by 1,000, and it to you at that moment, it appears that that's the answer. So you need to pay careful attention, to units. So that was it. Thank you and have a great day.